The objective of this project is to design a small-scale wind turbine that automatically aligns with the wind direction to maximize energy generation and maintain efficient performance under changing conditions. Our component list includes Arduino Uno R4, I/O sensor expansion board, DF robot wind direction sensor, RS485 to UART active isolated signal conversion module, extra long Arduino wire kit, L298N motor controller 12 volts DC 40 RPM motor, various screws, nuts, and washers, various wooden blocks, 1 1/4 PVC pipe, Walmart wind turbine 4x4 wood beam, 55 pounds bag of cement, and Arduino was used for all coding.
Now we can start with the code setup. First, since we're using a motor controller, we have to establish the pins that are going to communicate to our processor. After that, we have to establish a value, a tolerance within our code. This value for tolerance basically represents the fact that when the sensor gets closer to zero, meaning that it is perpendicular to the wind direction, it will stop. This happens at 0 degrees, but we want to have some tolerance, 10-degree tolerance, either minus or plus, so that the motor does not jitter. After that, we set up the hold wind direction sensor and do call an address from the previously stated library. Our setup is to establish the setup for our motor controller. We establish a baud and establish the initial condition of the motor to be off. Then we can finally start with the loop that's going to be running and creating the whole self-adjusting part of our project. We establish a wind angle, which the sensor is going to be continuously reading and causing the motor to rotate accordingly. Wind direction sensor is continuously reading an angle. We can finally establish a difference. That is basically the angle that it's reading and the 0-degree angle that we're trying to achieve, or within the tolerance as we previously stated. Over here, the tolerance comes back. The motor will rotate according to this difference. First case is that the angle is within difference. If this happens, we stop the motor and no motion has to be done, since the wind turbine is facing the wind head on. If the angle is not between the tolerance, rather from 5 to 180 degrees, this difference will be positive and the motor will rotate clockwise. We establish this by changing this to high and this to low. We establish the speed of the motor and print the direction in which it is rotating. If the angle is between 5 and 180, this means that the difference is negative. We change the inputs over here to low, high, meaning that it rotates counterclockwise. We establish the PWM, which gives the speed to our motor, and signal that it is rotating counterclockwise. That is how our code works.
This was our first test of controlling the motor with the code. We simulated the wind direction sensor, giving the motor an angle, and then our code turned the motor toward that angle. Once we got our code working and assembled the wind turbine, we tested it. As you can see, the wind turbine moves in the same direction that the wind direction sensor is turned toward.
The turbine, equipped with an RS-485 wind direction sensor, successfully detected the wind direction and used DC motor control via Arduino logic to rotate in the wind direction. Testing demonstrated smooth rotation and accurate alignment within approximately 10 to 15 degrees, confirming the system's effectiveness after implementing ramp up and ramp down features to reduce start-stop jerking. The generator produces a measurable voltage at moderate wind speeds, indicating that its power output is sufficient to power small electronic devices. Future work will focus on harnessing and storing this energy in a battery system for sustained use. During the construction phase, we utilized Tripp's father's power tools to construct and machine the joint between the motor and the turbine. Throughout the duration of the project, we utilized Dr. Khan's lectures and assistance in class to better understand how to present, code, and finalize our project.